For decades, black holes have been known as the universe's ultimate destroyers. Their gravity is so powerful that not even light can escape once it crosses the event horizon. They consume gas, dust, and even entire stars, leaving behind regions of extreme darkness. But what if a black hole could also help create something new? Recent observations made with NASA's James Webb Space Telescope have given astronomers an extraordinary opportunity to investigate one of the most unusual black holes ever discovered. Instead of remaining near the center of its galaxy, this enormous black hole appears to be racing through intergalactic space at incredible speed. Researchers believe it may have been launched from its original home after a powerful interaction involving multiple supermassive black holes during a galaxy merger. While scientists continue studying exactly how this happened, the evidence points toward one of the most dramatic events ever observed in galactic evolution. As this black hole travels through space, it doesn't move through empty darkness. It passes through enormous clouds of hydrogen gas spread across the galaxy. Its powerful gravitational influence compresses some of this gas, creating conditions that may trigger the birth of new stars. Behind the black hole stretches a remarkably long trail where astronomers believe fresh generations of stars are forming. This glowing wake extends for nearly 200,000 light-years, greater than the diameter of our own Milky Way galaxy. For years, scientists understood that black holes could both destroy and influence their surroundings. However, seeing one potentially contribute to large-scale star formation while moving away from its galaxy opens an entirely new area of research. Rather than acting only as cosmic consumers, black holes may sometimes participate in creating the next generation of stars under very specific conditions. The discovery has attracted worldwide attention because it challenges several assumptions about how galaxies evolve over billions of years. To strengthen the findings, astronomers combined observations from the James Webb Space Telescope with earlier images captured by the Hubble Space Telescope. Together, these observatories provide a more complete picture of the remarkable event. Although researchers continue testing alternative explanations, the evidence suggests that this unusual object represents one of the clearest examples yet of a runaway supermassive black hole interacting with its environment. The James Webb Space Telescope has also been studying another spectacular object known as ARP 220. Located approximately 250 million light-years from Earth, ARP 220 is one of the brightest infrared galaxies ever discovered. It formed when two massive spiral galaxies collided hundreds of millions of years ago. The collision compressed enormous quantities of gas into a relatively small region, triggering an intense burst of star formation unlike almost anything seen nearby. Using its powerful infrared instruments, Webb has looked through thick clouds of dust that hide much of the collision from visible light telescopes. For the first time, astronomers can study the galaxy's central regions with exceptional clarity. The observations revealed two bright galactic nuclei slowly moving toward one another as the merger continues. Around them, countless young stars are forming while enormous clouds of gas swirl under the influence of gravity. Long streams of material extend far beyond the galaxies themselves, evidence of the tremendous gravitational forces unleashed during the collision. These observations help scientists understand how galaxy mergers reshape the universe and how some of the largest galaxies may have formed over cosmic history. And yet, these remarkable discoveries are only the beginning. As Webb continues exploring deeper into space and further back in time, astronomers are finding objects that challenge long-standing ideas about the early universe itself. Some of the oldest known galaxies appear brighter, larger, and more mature than many theories predicted. Those discoveries are forcing scientists to ask an even bigger question. Did the young universe evolve far faster than we once believed? As remarkable as the runaway black hole and the collision inside ARP 220 are, some of the James Webb Space Telescope's most surprising discoveries come from much farther away. Webb was built to study the earliest galaxies that formed after the Big Bang. By collecting faint infrared light that has traveled across the universe for more than 13 billion years, it allows astronomers to observe the cosmos as it existed during its earliest chapters. Scientists expected these first galaxies to be small, irregular, and slowly growing. Instead, Webb has revealed a universe that appears far more active than many researchers anticipated. Some ancient galaxies are brighter, more massive, and more chemically evolved than earlier models predicted for such an early period in cosmic history. At first, astronomers questioned the observations. Could the galaxies actually be closer than they appeared? Were the distances being overestimated? To answer these questions, research teams carefully analyzed each galaxy's spectrum, measuring how much its light had been stretched by the expansion of the universe. Repeated observations confirmed that many of these galaxies truly belong to the earliest known generations of cosmic structures. These discoveries do not overturn the Big Bang theory. Instead, they suggest that galaxy formation may have progressed more rapidly in some regions of the young universe than scientists previously expected. Understanding why this happened has become one of astronomy's most exciting challenges. Another mystery involves the chemical makeup of these distant galaxies. Using spectroscopy, Webb can identify elements present in stars and interstellar gas by studying their unique light signatures. Researchers have detected elements such as carbon, oxygen, and nitrogen within some of these early galaxies. Because these heavier elements are produced inside stars, their presence indicates that multiple generations of stars may have formed and exploded surprisingly quickly after the universe began. The telescope has also provided valuable new information about supermassive black holes. Some appear to have reached enormous sizes much earlier than existing growth models can easily explain. Astronomers are now exploring several possibilities. Perhaps certain black holes formed from exceptionally massive gas clouds. Perhaps early galaxies supplied black holes with gas at unusually high rates. Or perhaps there are physical processes that scientists have not yet fully understood. At present, no single explanation has been confirmed. This uncertainty is not a weakness, it is how science advances. Every unexpected observation encourages researchers to improve their models and test new ideas against evidence. That is exactly what the James Webb Space Telescope was designed to do. Beyond galaxies and black holes, Webb is also helping scientists investigate the chemistry of the early universe. Its infrared instruments have detected complex carbon-containing molecules within distant clouds of gas and dust. While these molecules are not signs of life, they are important ingredients in the chemistry that eventually leads to planets and, potentially, living systems. Their presence suggests that the building blocks of complex chemistry became widespread relatively early in cosmic history. Each new discovery adds another piece to the puzzle of how the universe evolved from simple hydrogen and helium into the rich diversity of stars, planets, and galaxies we see today. Perhaps Webb's greatest achievement is not providing all the answers. It is revealing better questions. Every image, every spectrum, and every distant galaxy reminds us that the universe is more complex than we imagined. As future observations continue, astronomers hope to learn how the first galaxies assembled, how supermassive black holes grew so rapidly, and how the earliest generations of stars transformed the young cosmos. The James Webb Space Telescope has not rewritten the laws of physics. It has done something equally important. It has expanded the boundaries of human knowledge, showing that even after centuries of exploration, the universe still holds extraordinary mysteries waiting to be understood.